Hi, welcome to the Pre-Calculus lecture series. And starting today, we are starting a new section, a new chapter, in fact. So it's chapter 6. So we're going to this video, going to cover the section 6.1. So we started the trig functions in chapter 5, and we look at the trig functions definitions from the unit circle point of the view. So the chapter 6, we're going to take a look at the trig functions from the triangle, the right triangle approach here. So the first section we're going to take a look is how do we define the angles? And then we're going to see how to use the trig function if we look at it from the right triangle approach here. Okay, let's go ahead, go to our lecture notes, and let's get started. Okay, so the first things here, we know, we talk about in the section 6.1 is the angle measures here. So in fact, when we try to talk about the angles, we have two kinds of the measurements, right? So we have degrees, now we have radians, okay? So we know the degrees like a whole circles here, right? We say it's like 360 degrees. Okay, so now we're kind of very familiar with degrees. So what is the radians here? Okay, so first let me write it out, the definitions of the radians measurements. Then after that, and then we will take a look at some, look at it from intuitive point, what is that? Okay, so we say if a circle, okay, of radius 1, okay, and then with the vertex of an angle at each center. Okay, and then the measure in radians is the length that of the arc that is the arc that subtend the angle. Okay, so let's take a look. So what is that means here, right? So like in here, you know, if I have a, okay, so let's take a look here. So in here, if I have unit circles here, right? So the radius here is 1 here, all right? So if, okay, so like if I say the one, what is the radians here? So this is the angles, right? So this is the angle theta here, right? So that means if the length of this arc, okay, so the radians is the length of this arc, you know, like subtended by the angles here. So that's why, so if here, if the length is 1, okay, if length is 1, that means the angle is 1 radians, right? So if the length is 1.5, that means the angle is measured at what? At 1.5 radians. Some people still say, oh, I don't really quite understand what that means here, okay? So let's take a look here. So this is the one, I kind of, you know, this is the graph I kind of like, you know, it's like in here. Okay, so in here we say, okay, so if this is your unit circles here, all right? If this is your unit circle, this is the radius is once here. So we know the pi. So we know the pi is equal to the 3.14159 somethings, right? So if you times like a 2 pi, this will give you 6.28, da, 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 da. So what's that means? Okay, that means, okay, so in here, if you start in here, then you use like the scissor, cut out this circle. So if you use a scissor, cut out this circle in here. Okay, so you say, okay, I'm cutting out, break this. So think about this circle is like a rope. You cut it out, then you cannot straighten it up. So that means you pull this circle up, so become a straight what? Because it's straight lines here. Okay, after you straighten this one up, so right, you cut in here, and then you kind of pull this curve straight, become a lines here. Then from here to here, the distance, if you physically use your ruler, if you're to measure it, right? So the distance will be 6.28 something. So here depends on how accurate your ruler can measure it. That's what we define like a radian. So that means the whole circle, the angles, the whole circle is what? Is 2 pi. That's what that means. That means if you cut this one out, the whole circle is 2 pi. That means you straighten up these lines here. The curve here is 6.28. That's what we mean is the radius here. Okay, so like in here, so let's take a look here. So take a look at some examples here, right? So we did this examples before, right? So we say, okay, if this is a unit circles, right? So I think we all know this angles here, right? So this angle is a pi over 2, right? So it's a 90 degrees angle. So this is a pi over 2 here. Okay, so what's that mean? That means the pi over 2, that means this arc, right? This arc is pi over 2. So if you put a 3.1415 divided by pi over 2, right? So what you will get here, so you will get something about 1.57, right? So that means if you use, if you cut this arc out and straighten that up, and then you use the ruler to measure it, the length of this arc is 1.57. All right. And then the same thing is here. Let's take a look at other examples here. So the examples here, right? So if this is a unit circles, right? So we all know, like this angles here from here to here, right? So that means half of, so what is that? It's a pi, right? Because the whole circle is 2 pi. So what's that mean? That means the arc here, the length of this arc, right? So this length of the arc is pi, is 3.14159 something. That means if you cut out this arc and straighten it up and then let it become a straight line, then you measure that line, that is 3.14159. That is how do we define the radians here, all right? So the radians, is the measure of this angle, the radians is the length of that arc. So like in here, if I have like, any angles here, if I can measure what is this arc here, then I know what is my radius here, okay? So now let's take a look at the one very important thing here is relation between the radians and the degree. So we know the 360 degree, the whole circle, a whole circle is 360 degrees, correct? So the 360 degrees, so for degrees, the typical will have a notation like this is degrees. If you do not see that little O, that means it's radians, right? So the 360 degrees here is going to be equal to how many radians here? Is the whole circle is 2 pi radians. All right. So now if you simplify it a little bit, so you can get 180 degrees is equal to what? pi radians, right? Because you divide by 2 both sides. Okay, so now in here we said if you want to convert, so if you want to convert degrees to radians, okay, so you know that means in here, if you simplify this a little bit, that means that means 1 degree is equal to what? Pi radians divided by 180. So you want to convert the degrees. So whatever the degrees, what you need to do is here, you need to multiply, right? You need to multiply the degrees with what? Pi radians of 180 degrees. Okay, so the same ways here. So that if you want to see convert radians to degrees. Okay, so from the same things from these relations, right? So from this relation, I know, okay, so if you divide it by pi, so if 180 pi is equal to what? 1 radius here, right? So how do you do from the radian to degrees? So you need to do what? You need to multiply what here? 100 over pi, right? 180 over pi here. So do you see that's why the reason why I kind of color coding here. So make sure you understand. Okay, so now let's take a look at examples here. So let's say express the 60 degrees in radian. Okay, so 1 degree is pi radian over 180. So 60 degree will be 60 times what? Pi over 180. So you cancel here. So what is 60 degree? It's a pi over 3. Or easy way to check, you just put a pi over pi is 180 divided by 3 is equal to 60. Yeah, that's what we have here. Okay, so then in here, how do I express the pi over 60 in degrees? So you can just say pi over 6, I need to times 180 over pi. So pi and the pi cancel, and this is 30 degrees here, right? Or you can just use 180 divided by 6 because you kind of, the pi is equal to 180 degrees, right? So it's pretty straightforward. Okay, so now, so let's take a look at the next definition is the standard position of the angle and the coterminals here. Okay, so we say an angle is in the standard position if it is drawn in XY plane, okay, and the vertex is at the origin, okay, and its initial side is on the positive x-axis. Okay, okay, so what is the coterminals here, right? So we say the two angles are coterminal if their side coincides. It's kind of like the same, like just like the names of coincide, right? So coincide here. So if that means that the sides are the same here. Okay, so let's take a look here, right? So that means if I have angles here, okay, so it's in the standard position. So let's say here, this is my angle, okay? So let's use a color blue here, right? So if this is my angle, right? So I said the next angle is here, right? So I can do here. So this one's here, if I do like this way, instead of swing the counterclockwise, if I swing this way, this red angle, I call the theta 1 here, right? So the theta 1 and the theta, look at what happens here. They both have the same starting side and end side, right? So this side, this rays here, we call it, this is the terminal side, right? So both the theta and the theta 1, they end at the same things, right? So we say have the terminal side. So the same ways here, let's take a look at another coterminals, right? So if the same things here, if this is my theta, okay. So if I have another angle, let me see here, I use the green one. So if this angle start the same things, go dun 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 here. So if this angle is theta 1 is here, so the theta 1 and the theta is the same things, right? Oops, why they get rid of my curve here, right? So theta 1 and the theta, those are the coterminals here, okay? So that means you can always turn around 200, 360 degrees, and then you always can get a coterminals here, okay? So let's take a look at some examples here, right? So let's say to find some angles that with the angle 30 degrees have that are coterminal with the 30 degrees. Okay, right? So now let's take a look here. So 30 degrees here. So I can do like this, right? Okay, let's see here. This is 30 degrees. So let me use the blue one here. So this is a 30 degrees angle. Okay, so it says find the coterminals here. So what is the first coterminal I can find? I can, just like we did before, I can do the whole circle and then back here. So what is this coterminal? So this is a theta 1, right? So what is the theta 1 for this situation? We'll have the coterminal is a 360 plus what? Plus 30. So it's 390. All right. Let's take a look at another way to see we can find another coterminals here, right? So it's the same ways here. Instead of going this way, what I can do, I can go this way. The blue, the green one, this is theta 2 here. So I turn the clockwise, so it's negative. So right now I ended the 30. So then this is my theta 2 here. So clockwise is what? So it's negative 360 plus 30. So it will give me negative 330, right? So be careful, I need to put the degrees here. I need to have a good discipline to put the degrees here. All right, so now those are the two coterminal angles, right? Okay, so now let's take a look at part B here. The part B, okay, so the part B is here, they say the angle is pi over 3. So we say, okay, here, this is a pi over 3 here. Let me use the same blue one here. So this is what? Pi over 3 here. Then let's say, hey, let's find the couple terminals here. So as always, we can try to do the positive one. We do the whole circle and then end here, right? So let's is the coterminal. So this is the theta 1. So what is the theta 1 here? Will be 2 pi, the whole circle is 2 pi plus pi over 3, right? So it will give you the 7 pi over 3. Okay, so now we can do the same ways here, right? So we can do like this way, go do. Of course, you can just like do many circles. You can do the same way. So the green one says theta 2. So the theta 2, because I rotate clockwise, so it's a negative 2 pi plus pi over 3. So what is this angle? It's negative 5 pi over 3. So both those are the what? Both these are the coterminal angles here. Okay. So now the next things here, next examples here we talk about is find an angle with measurements between 0 and 360, and it has a coterminal 1290. Okay, so the first things here, I need to know the 1290 is how many complete circle. So how many completed circle I can have, right? So I know the 360 is one completed circle, right? So in here, I can have a total 3 completed circle, right? So 3 completed circle give me 360 times 3. So what is this one here? 1080, right? I cannot have a 4 because if you times 4, what are you going to have here? You have 100. So 4, if you do 4 circles here, what is the angles here? You will get a 1440. It's bigger than the 1290. So I know I cannot have this ones here. So I can have 3 complete circles here. So after 3 complete circle, what is the angle left? So you use 1290 minus 1080. You have 210 degrees left. Okay, so let's see what that means here, right? So here, okay, that means I'm going to here, right? So that means I'm going to 1 circle, 2 circle, right? Then 3 circle. After 3 circle, I still have 210. So this is 180 and 210 is here. Okay, so this is, right? So the 210, the last ones here, I should have used a different color. The last one, 210s here, after you go here. So this part, that's the how much left, right? So this is the part. So the coterminals here is what? Is 210s, right? Okay, so now the next things here, we're going to talk about length of the circular arc. Okay, so that means the length of the circular arc here. So remember, right? That means if I have a circles here, right? So I know if this is a unit circle, so if the radius, is 1, okay? So if radius is 1, and then if you have angles here, so let's say here, if you have some angles here, if this angle is in radius, right? So if this angle is theta, of course here the theta is in what? In the radians, right? So remember from the radians definitions, then what is this arc here equal to? This arc, the length of this arc is equal to what? Is equal to theta. Okay, so this is for the situations if this is under the unit circles, right? That's what we did before. Okay, so this is on the unit circle, so the radius equal to 1. Okay, so now how about if I have any circles here, right? And any circle, so this will be any circle, and it's not the unit circle. So like a unit circle, so the length equal to the angles here, right? That's how do we define, right? So for any circle, if the radius now, instead of the r, if this radius instead of 1 is equal to the r, and then you have any angles here, okay? So if you have any angles here, this is the theta. Then what is the length of this arc here? right? So the length of this arc, so, from the definition, the length is equal to theta for the unit circles, right? So the length of this arc is equal to what? Is because your radius changes, so it will just be the r times theta here, okay? And the length we defined as the s. So that's why we have this very good formula is S equal to the R times theta here. Okay, so now let's take a look at some examples here. So example number 4, you tell you, they said, find the length of the arc with radius is 10 meters and subtend a central angle to a 30. Okay, so be careful here. The formula we just introduced, the theta equal to the r, s equal to the r theta. Theta has to be in what? In the radians, right? Because that's what is our definition. Okay, so for the part A here, first things I need to do is what? I need to change the 30 degrees, right? So 30 degrees, I need to change it to the radian. So it's 30 degrees times the pi over 180. So I will have a what? So it's a pi over 6 here. All right. So then the S here will be R thetas, right? So R thetas here. So what is the R? R is 10. What is the thetas here? Is pi over 6. So I have a 5 pi over 3. That will be the length of the, this arc here. Okay, now let's take a look at part B here. They said a central angle theta in a circle of radius is 4, and subtend the arc of the length is 6 meters. Find the measure of the theta. Okay, so we know that S is equal to the R theta. So they tell you the length, the arc length here, right? The arc length here is 6. That means this is the S. So S is equal to the 6 equal to R. R is what? R is 4, right? So R is 4 times the theta. So what is the theta here? Theta is 6 over 4. So it's 3/2 radians. Right? Okay, so if you go back to our definitions, right? So we know that in general, the length of the arc is equal to thetas, right? So now the special case, so for the special case, we all know the circumference. Circumference of the circle, I think you learned this when you were in the 9th grade in the geometry. So the circumference we say is 2 pi r. Okay, so now let's take a look. This is true? We know the S here is the length of the, so right now if you want to count the circumference, is the whole circle. So then what is the r? R still in here. What is the theta, the whole circle? Is 2 pi, right? So that's why we defined the circumference is 2 pi r. So it's a match what are our definitions here. So it's a special case of our definition. It's pretty cool, right? Okay, so now let's take a look at the area of the circular sectors here. So the areas here, so we say in a circle of radius R, then the area, capital A, of a sector, okay, with a central angle of the theta radians. Now we know the area is, this is what our formulas here, area is 1/2 r square theta here, right? Okay, so now let's take a look at our special case to see in a match or not. So the special case is the area of a circle, a whole circle. Right, so we all learn that what is the area of a whole circle. When we were in the geometry, our teacher tell us it's a pi r squares, right? So let's see, you know, if I use these formulas, do I get a pi r squares, right? So this is 1/2 r squared. So if a whole circle, what is my theta here? My theta is 2 pi's, right? So 2 and 2 cancel. That's why I get a pi r squared. Is match what I learned, you know, in our geometry class. Okay, so now let's take a look here. So we said examples here. They say find the area of the sector, and with the central angle is 60 degrees if the radius is 3. So the same things here, right? I need to change the 60 degrees to radians, right? So because this is the measure of the radius here, be careful. So 60 degrees is what? Is 60 times pi over 180. So how many radians here? Pi over 3 radians, right? Now I use this formula. So what is my area? My area is the 1/2, the r radius is 3 pi r squared. So it's 9 times pi over 3. So what I have here, you cancel here, it's 3 pi over 2. So I know the area of this sector is 3 pi over 2. Of course, the union is meter squared. Okay, so let's take a look the linear speed and okay, so the linear speed and the angular speed here. Okay, so what is the linear speed? Okay, so let's take a look here. Let's take a look here, right? So if I have a circles here, okay, and I have a person standing here, okay, then I'm start to kind of wrong here, right? So this is my circle changes here. So like if this circle change, if this angle changing a certain speed, so this person, right? So this person is running on this boundary here, running here, right? So if it takes like the then person come to here, if it take like the t seconds or t minutes, whatever your times measures, right? So it's take the time t, all right? So let's say we say time t. Doesn't have to be seconds, doesn't have to be minutes. So we say it's a time t. So could be seconds, minutes, and what? And like hours or whatever. So then I know the red ones here, this is the length of this arc, right? So that means that total distance between these 2 points. It takes time to run it. So what do we call this ones here? This is we call this the linear speed. You say, hey, this is the arc. Why I call this linear speed here? It's because, like we say, this arc, if you cut this arc, you straighten it up, it will be a line, right? So that's basically is the distance from the starting point to the end point, take how long to run. So for example, if you are starting in the city A to city B, the city A to city B is 100 miles. If it take you 2 hours to get there, your speed is 50 miles per hour, right? So here, this is the same thing. So the linear speed is what? It's the S over what? It's S over T. And I use the notation. So what is the notation I use here? I use the notation V, all right? So the V is my linear speed, okay? And then the next things here I'm going to talk about is the angular speed. Okay, the angular speed is how fast this angle changes, right? How fast this angle changes. For example, from 0 degree, boom, the angle changes to 60 degrees in time t. So how fast the angle change? We call it the angular speed, right? So the angular speed, basically, this is the look here, this is the angle, right? How fast from 0 to here, right? So now that's why I can say the angular speed will be what? Is the angle you change, right? So that's the total angle you traveled, right? Over times what? Over times t, see here. This is what we call the angular speed. And what is the notation I'm use here? I'm using the W to represent the angular speed, right? So make sure you know the notation, the angular speed and the linear speed, right? So the angular speed is how fast this angle turns, right? So like sometimes, you know, since some rotation, the wheel turn a lot faster than some other wheel. So that means angular speed is a lot faster for certain wheels here. Okay, so now let's take a look at some examples here. So in here we said, okay, so we said a boys, right? So we said a boys rotate a stone in a 3 feet long slam at the rate of 15 revolutions every 10 seconds. Find the angular and the linear speed, right? So that means I have a boy here, right? So he's playing with the things, so he's throwing a stone in a circle here, right? So he has a strings here holding that, so the stones here go. So he was doing that, rotate this stone, the circles here. So the rotated stone in a 3 feet long slam, right? So that means what is here? My radius is what? My radius is so my radius is 3, right? Okay. So now in here, it said rotate 15 rotation in 10 seconds here. So we know 1 revolution, that means 1 revolution is a whole circle, right? So it's 1 whole circle. So 1 whole circle is what? Is 2 pi, correct? So now I have 15 revolutions. That means 15 circle. So the total angle change is 15 times 2 pi. So it's what? So it's 30 pi radians. That means my angle changed, you know, like 30 pi, I did a 30 pi radians over how many? 10 seconds. So my angular speed will be total how many, how fast this angle changes, 30 pi over what? Over 10 seconds here, correct? All right, so now that's why my speed here, so it's 3 pi. Remember the top here is, so your units is radians. Now your bottom is what? Is per seconds, right? So it's 3 pi radians per second. It's pretty fast. Okay, so now we want to find the linear. Linear is, you know, how, you know, like what is your travels, right? So how is this stone travel? So basically, the stone goes through a whole circumference for 1 revolution. So I know the stones here, right? So it's travel. So total travels here for each circle. For 1 circle is 2 pi r, right? So circumference is 2 pi r. R is 3. And how many revolutions here? I have 15 revolutions here, correct? So that means this is 90 pi radians. Okay, now how long I travel? Take me 10 seconds. Take 10 seconds for this rock to travel. So the linear velocity will just be s over t. So it will be 90 pi over what? Over 10. So it's 9 pi per radians, right? Okay, oh, I'm sorry, it's not a radians here anymore. So it's a 9 pi, okay, per 9 pi per foot over seconds here, because this is the total distance, right? So the circumference, so it's 2 pi times 3. So this is the I'm sorry, here, this is not 9 pi radians here. This is 90 pi foot here. All right. Okay, so now the last things here we want to see, is there any relation between linear and the angular speed here? All right, so let's take a look. So we know the angular speed is theta over t. So that means, okay, so it's theta over t, right? So that means t is equal to the theta over w. Then the linear velocity is s over t. What's that mean? That means t is equal to the s over v. Ha, both of them equal to t. So what's that mean? That means theta over w is equal to the s over what? It's over v here, right? Okay, so now let's take a look here. So if you do a cross product, okay, so if I do a cross product here, then I can come out with theta times v is equal to the s times w's, right? Now, so the v is equal to the s times w over theta. And then the same way, what is s? The s is the arc length, so it's r times theta, w the theta. Oh, wow, that's very beautiful. So theta, theta cancel. So finally, I got this very good relations here. So my annual speed is equal to what? My annual speed is equal to the radius times my angular speed, right? Wow, it's very, very beautiful formulas here. Okay, so now let's take a look at some example to see how do we do this. So we say a woman is riding a bicycle and the wheel of this bicycle is 26 inch in diameter. All right, so try to trick us. So if 26 in diameter, so what does that mean? So the radius equal to what? 13. If the wheel rotates in 125 revolution per minute, find the speed she's traveling. Okay, so wow, it's 125 revolution. So same thing, one revolution is equal to what? The whole circles, right? One revolution is equal to the whole circle. So it's equal to the 2 pi. So 125 revolution. So that means it's 125 times 2 pi. So what is that? So that means, wow, they travel pretty fast. It's 250 radians, right? So this is 250 radians. And so they said per minute. Oh, okay, so it's already just divided by 1. So it's 200. So what is the angular speed? Okay, so angular speed will just be 250 divided by 1 minute, right? So this is 250 radians per minute. And then they say, hey, what is the speed this person travel? So then I use this good formula. So the speed that this one's travel will be the radius times the angular. So the radius is 13 times 250. So you can change it to the decimal. So this one will be 10.212. 10.212.2. So what is here? What is the units here is inches, right? So that means travel total this many inches here, right? So now this is how many inches per minute, right? So this is inches per minute here. Okay, so now they want to ask to see, so this is kind of unit transfer. So it's how many miles per hour? Oh, gee whiz. Okay, so we know the 12 inches is 1 foot, right? Okay, so 12 inches is 1 foot. And then 580 feet is equal to 1 mile. So the first things I need to see 10 to 1, 10,200 to 110. So this is 10.2 inches is how many miles? So I will just say 10,210.2 divided by 12. And also then I divided by 5,280. And this one will give me the how many miles, right? So let's say 10,210.2 divided by 12 equal and divided by 5,280. So it will be 0.1611 mile per minute, right? But now your problems ask is how many miles per hour. So that's why I need to use 1611 times what? Times 60, right? So if you times 60, you will get a 9.67. Right, so this is 9.67 miles because the times here is what? Per hour, right? Okay, so that will be our final answers here. Okay, so that's it. That's the section 6.1. We talk about one very important measure of the angle, that is the radians, right? So the key formulas here, the angular speed, the linear speed and their relations, and how do you find the arc length is all highlighted in red, right? So make sure you remember those things, okay? All right, that's it. You guys have a good day, and I hope you start to get a better understanding what is radian means. All right. Okay, nice to talk to you and looking forward to talk to you in our next videos here. Okay, bye-bye.